Hi, welcome to my demo of Assignment 1 for Security in Computing and Information Technology. My name is Trung, and my SID is S39783330. So let's just get started. Let me just clear this. As you can see, I've already created an encryptions directory. So now I'm going to create a new file called secrets.txt. And then I'm going to write some text into it. So we're going to see the contents of the file. As you can see, the file is in there. Now I'm going to encrypt this file using a command with OpenSSL. So you use OpenSSL ENC for encrypt. I'm going to use the AES 256 CBC algorithm. For the input file, it's going to be secrets.txt. The output file, it's going to be AES encrypted.txt. Additionally, I'm going to use PBKDF2 for an extra layer of security and some iterations, which I'm going to let it iterate for 100. And I'm also going to salt the file. So now I'm going to enter the password. So I'm using password as the password. Now we're going to see the contents of AES encrypted.txt. As you can see, all the contents are encrypted. Now we're going to decrypt it. So I'm just going to reuse this command, but instead of using secrets.txt as the input file, I'm going to use AES encrypted. And for the output file, I'm going to create a new file called AES decrypted.txt. And all the commands are the same. I'm just going to add a /d here so that it can decrypt. It can decrypt for me. So password. Let's see the contents of AES decrypted.txt. And as you can see, it's the same as the secrets.txt file. And that has been the symmetric encryption with OpenSSL. Now I'm going to move on to asymmetric encryption. So let's just start off with creating a key pair file. So we can use the private key and public keys. So we OpenSSL generate the RSA to generate the key pairs. And the output file will be key.pem with a 2048-bit value. And then I'm going to extract the public key from the private key in key.pem so that we can use the public key to encrypt the files. So pub out, so it indicates the public key, and it's also the out file. So the out file, I will name it pub.pem. So it has written the RSA key. Now we can check the details of the key information. So open SSL RSA for the algorithm, the input file being key.pem. You can see the as in the text and no out. See everything's running correctly. Now we're going to encrypt the secrets.txt file again, but with asymmetric encryption. So I'm going to use OpenSSL with a key util, UTL. Input file being secrets.txt, and the out being RSA encrypted.txt. Here's the fun part. Is using the public key input file being with in key, using the public key we just created, so pub.pem, and we also need to include an encrypt command here. It has encrypted the file. You can see the contents of RSA encrypted.txt. See, it has been encrypted. Now we can decrypt it. So open SSL, decrypt it with the private key. So P key util. The input file will be RSA encrypted this time. The output file will be RSA decrypted. .txt. The in key will be the input key this time will be the private key. So we're using key.pem and using the decrypt command. We're going to see the contents of the RSA decrypted file. As you can see here, it's the same as the secrets.txt file. So that has been symmetric and asymmetric encryption with OpenSSL. But we can also do the same tricks, but with different tools. I've prepared 2 extra tools to showcase the same concept. So this is, I created 2 Python files to showcase symmetric encryption and asymmetric encryption. Here, I'm going to explain the code a little bit. So this is the get key function, which it will create open the key.key file. But if it's not created yet, then Fernet will generate a key. The Fernet instance will generate a key and then write it to a new key.key file. For the symmetric encryption, I use the cryptography library of Python, which supports a symmetric encryption with the Fernet class. So for this encrypt and write function, I initialize the Fernet instance and then put the key into it, and then it encrypted the message, and then I write it to an encrypted message.txt file. When for this decrypt and read function is this almost similar to the same. It will read the encrypted message.txt file, and then it will use the Fernet instance key and decrypt the message. So how about I just run this to see, as you can see here, the message is, this is a secret, so hush and let's move on. So I can initialize a key value here, a key variable here, using the get key function. And then I write it to the encrypted message.txt file. And then I print it I printed. And as you can see here, the encrypted string and decrypted string is the same as the original string. So not, then this is the asymmetric one. It's a little more complicated. So it will open a public key.pem file, and it uses the RSA library with Python. It opens the public key, and then it using the public key.load pkcs1 function, it can read the public key and private key separately from the public key.pem file. And if and then the same logic applies, if the file hasn't existed yet, it will create a new file with new public keys and with the new key pair values. And the encrypt and write message, instead of using the same key, for the encryption, it uses public key, and for the decryption, it uses the private key. So we can write it right here and run the file. You can see here, the decryption used it decrypted and encrypted it correctly. Here we can see a private key.pem, public key.pem, a message.rsatxt, encrypted message.txt. As you can see, even Python can be used the same as OpenSSL. I also have another tool to show you. Actually, Node.js supports no encryption because Node.js and JavaScript has a built-in cryptography library. I'm just going to explain some of the code here. This is I'm going using the AES 256 CBC algorithm, just like before with OpenSSL. I'm initializing some of the file names for the key and the initialization vector file. For here, the same value, the same logic applies in the Python tool in Python. So I read from the file, and if it doesn't exist, then it will create a new file. And you can see here, we're using the crypto library to create a cipher using the algorithm and buffering from the key and buffering from the initialization vector. So we let encrypted AES equals cipher AES. So we let this variable be updated with this text, and then it gets encrypted, and then it writes to an encrypted AES file. And after which we can for this I use the create decipher IV again to decipher the encrypted file. So you can see here it writes the file into a decrypted AES file, decrypted AES variable here. So I'm just going to run node.index.js. See the keys have been created. Here's the decrypted message. It's the correct message. This is the encrypted message. It's been encrypted correctly. Now I'm going to show you the asymmetric encryption using Node.js and JavaScript. So the logic is similar to the symmetric one, but we're just using a public key and a private key, and we're using the RSA algorithm instead of using IV and using initialization vectors. So we create we read from the public key and private key files, and they don't exist. If they don't exist, we create new ones with the set bits, so 2048, using the PEM format to create PEM files for each. And here's the plain text that we want to encrypt, the text to be encrypted, using this encrypted RSA variable. So using the crypto library and public encrypt method, you can use the public key and buffer the plain text. And then the same logic applies down here. We use the we read from the encrypted file and then decrypt it using private decrypt using the private key and encrypted message RSA. So I'm just gonna run node index.js again. You can see here it encrypted and decrypted correctly. We can check the files right here, private key PEM, public key PEM, encrypted message RSA, and decrypted message RSA. So this has been my demo. Thank you for listening, and that has been it. Thank you.